where there's a value in with the theta, we're still going to start it the same way, where we're going to try to get theta alone. So we're going to go step by step, and we're going to use the same steps we've been using so far. So let's start isolating theta. What could I move first? What? The 1. Let's subtract the 1 to the other side. So again, opposite operations, subtract it to the other side. Again, keeping it balanced. Always thinking about an equation like a balance, that if you do something to one side, you must do it to the other. Okay, there we go. Step 1. What else can we get rid of pretty easily? The 2 out front. What do I need to do with that? Divide it. It's being multiplied, so we do the opposite, so we're dividing. Cosine 3 theta equals -1/2. Okay, so here's where the order becomes significant of how we think about this. The next thing we want to do, so yes, I agree, the 3 is problematic, but I'm going to get rid of the cosine first, right? Because the cosine is kind of more overreaching. We're taking the cosine of that whole thing, the 3 and the theta. So I'm going to start by taking the inverse cosine. Okay. When I go to take the inverse cosine, do we have a Buddy the Elf moment? Do we know him? Do I know -1/2 on my unit circle? We do. So I'm not going to take out a calculator. I am, however, going to rewrite 3 theta because that's still there. So this is going to cancel, right? But I still have my 3 theta. Okay, there are 2 spots where the cosine is -1/2. What are they? 2 pi over 3 and okay, do we agree with both of those? Let's double check. So here's my unit circle. So as I'm going through these, if I do, let's see, I need it to be, the cosine is 1/2, so it'll be up here. So that will be 2 pi over 3. And then I'm going to need the same thing down here. 3 pi over, yeah. Okay, so I like 2 pi over 3 and 4 pi over 3. Sorry, I had to get inside the unit circle and make sure I agreed there. We're good with those? Okay. Now, let's pretend we have the whole thing written out for just a second. So let's say we have 3 theta equals 2 pi over 3. What would I write with it? Plus what? 2 pi k, where k exists in the set of integers. Okay. Have I truly solved it for theta, though? No. If this were anything else, so think about just like an easy problem. Pretend for a second it was just like 3x equals 15, like back in the good old days. How would you solve that?
Divide the 3.
Divide the 3, or could I even multiply by 1/3? Yes. Okay, so that's what I'm going to do. I'm going to multiply by 1/3, but like all the things. So on this side, now I just have theta left over. On this side, what am I going to get when I multiply this fraction to this fraction? 2 pi over 9. 2 pi over 9. And it also is going to get distributed here. It's going to impact the period too. So 2 pi over 3k. And k has to stay an integer. It doesn't impact that. Okay? So that's going to be one of our solutions that we have. The other solution, 3 theta equals, we had 4 pi over 3 plus 2 pi k, where k exists in the set of integers. Am I going to do the same thing to this one? Yes. So I'm going to multiply everything. Oops, I want to do it separately. I'm going to multiply everything by 1/3. So theta equals, this is going to give me 4 pi over 9 plus 2 pi, or 2/3 pi k, where k exists in the set of integers. So my solutions for part 1 are this and this. So believe it or not, there's a second part. What does the second part say? 0 to 2 pi. All right. So I have a solution at 2 pi over 9, right? I also have a solution at 4 pi over 9. So do you see how I'm in terms of pi over 9s? Yeah? Okay, so let's think about 2 pi, but let's think about it in terms of pi over 9s. Do you agree that 2 pi is the same as 18 pi over 9 if we kind of switch it so it matches to what we're working with? Right? That's still 2 pi. Agree? Okay, so we need to have that there to kind of like, that's our benchmark. So if we go above 18 pi over 9, we're out of that window of solutions. Okay, let's look at what we need to add. What are we adding each time? 2 pi over 3. Can I actually really, though, add that easily to something with a denominator of 9? No. So what am I really adding? Plus 6 every time. Okay, so let's add 6, and I get to 8 pi over 9. Does that still fit in my window? Okay. Let's add 6 again. I get 14. Does that still fit in my window?
Yes.
Let's add 6 again. 20 pi over 9. Is that still in it? No. So I heard a couple people saying, why is the weird lady adding 6? Because in order to add these two together, I need a common denominator. So I'm going to multiply this by 3. And if I multiply that by 3, I also have to multiply the 2 by 3. So I'm adding 6 pi over 9 every single time. That makes sense? Okay. All right. Let's go to the next one. It's going to be the same thing, right? We're going to add 6 pi. Okay, so let's add 6 pi over 9 again. If I add 6 pi, what do I have now? 10. 10 pi over 9, does that still fit in this window? Okay, add 6 again. I'm up to 16 pi over 9. Does that still fit? If I add 6 again, I'm at 22. Does that fit? No. So I have these lovely 6 solutions that are for part 2. So this was part 2, and then these highlighted answers here were both for part 1. Are we okay? Did I lose anybody? No, we're still making it. Okay. So these are the solutions that fit in that window, and then these were all the solutions. So you need both of those highlighted pink equations. You can't just have one or the other, you need both. Okay? All right, next one. I went over part B a little bit. Okay, tangent theta. We're only doing 2 examples. Plus root 3 equals 0. Okay. What would you do first to start solving for theta? Subtract root 3. Tangent of theta over 4 equals negative root 3. Okay. Now, I know that the divide by 4 looks very problematic, but because it's all like within the tangent, I need to deal with the tangent first and make that go away, and then I need to deal with the divide by 4. Okay, how can I undo the tangent? Inverse tangent of each side. Okay, so I get theta over 4, and it's important to remember that I still have that divide by 4, equals. The nice thing here is I'm only going to end up with one equation, right? So we don't have to deal with 2 separate things like we did in this one. Okay, on your unit circle, in terms of tangent, because we only look at those first 2 quadrants, if we have a negative tangent, it has to live in quadrant 2. Where is the spot, do you know, where it's going to be negative root 3? I feel like this is like the $1 million question. It's not an easy question.
2 pi over 3?
Yes, it is 2 pi. Look at you. Good job. All right, 2 pi over 3 is the correct answer. And if you don't believe, if you're not a believer, or if you're not sure, you're just not sure, you would go to your unit circle, you would go to this location, and you would do your sine divided by cosine, and it is going to give you negative root 3. So if you are not a believer, then do that, and you will see that, yep, we're right. Okay, what do I put with it, though? Plus pi k, because it's tangent, where k exists in the set of integers. So many little rules to remember. It's easy to think, oh, it's 2 pi k still. All right, now, think back to a super easy problem. Let's say you had x divided by 4 equals 10. What would you do? You multiply by 4. So what do you think we're going to do here? Multiply by 4. So yes, let's do that. And remember, I kind of like to put parentheses around it because it impacts the first part, that fraction, but it also impacts what you're adding to it every time. So theta equals, I'm going to get what for this one? Yep, 8 pi over 3 when I multiply, because remember this is really like 4 over 1, so 4 times the 2, 1 times the 3, plus how many pi k? 4 pi k, where k exists in the set of integers. So this is the answer to part 1. Because part 1 said, give me all the solutions. Part 2 says, give me solutions in the window 0 to 2 pi. Okay. We're in pi over 3s. So if we think about 2 pi in terms of pi over 3, it'd be 6 pi over 3. Agree? Okay. So we can look in between 0 and 6 pi over 3 for solutions. Problem. We're already out of it before we can even do anything. So for part 2, there are no solutions in that window. So no solutions. That is it. I love that you're threatening me, though. That better be it. What was the end of that threat? No solutions in this window. And it's not that there are no solutions, right? Like we found solutions. They are these, but there are no solutions that live. There are no solutions that live inside that window that they gave us that they were interested in. Does that make sense? It, almost like that problem we did on the homework where we went to solve it and we were like, well, it doesn't live in the window it needs to. Okay? Good? Okay, you got a good amount of time again to practice this, so you can ask for help. We have not a ton of problems again, but enough to get you some practice. Page 528. Shh. Listen, because I still want to say one other thing. I always like to say things, you know that. This is the homework for tonight. We are done with chapter 7. There was a lot of stuff in chapter 7. It was, yes, a lot. There's no way we're going to have school on Thursday with how much snow is coming. It's just not, it's not going to happen. Now, if I'm wrong, yeah, I know. If I'm wrong, you can be really mad at me. And you can just look at me with evil stares all hour. And Rogan, you can give me more ultimatums that better be done. Listen. So my plan, because you know I always like to have a plan. My plan is to do the worksheet review tomorrow. And then I don't think we're going to have school Thursday. I will be very surprised if we do. I will see you again on Tuesday, next week, and we will do a whiteboard review, and then we will test on Wednesday. If there is no snow day, we'll have a bonus review day. So we'll have 3 review days instead of 2.